Okay, so here we're trying to prove that 2 power n is bigger than or equal to n squared, where n is bigger than or equal to 4. So first we prove it for the first case. Let n equal 4. So we have 2 power 4 is bigger than or equal to 4 squared. So that is 16 is bigger than or equal to 16. So that's true. Now we assume that it's true for case k. So that is 2 power k is bigger than or equal to k squared. And we need to prove, we're required to prove now, that it's true for case k plus 1. So this is what we're trying to prove. So the approach I take here is, first let's start with what we're assuming to be true and try to introduce a k plus 1 into it. The easiest way to do that will be to multiply both sides by 2. So you have 2 times 2 power k is bigger than or equal to k 2 times k squared. This is actually 2 power 1 and 2 power 1. So these go together and become 2 power k plus 1 is bigger than or equal to 2k squared. And if I'm assuming that this is true, then it follows that this is true, because I just multiplied by 2. Now what we try to do next, we consider the claim that 2k squared is bigger than or equal to k plus 1 squared. And we try and see if we can prove if this is true, because if you look at what we have, if I call this A and this B and this C, we're saying that A is bigger than B. We've shown this, and now we're trying to show that B is bigger than C, so therefore we'll have A is bigger than C, and A is 2 power k plus 1 and C is k plus 1 squared. So this is what we're trying to ultimately prove. So let's see if we can show that this is true. Two k squared is greater than or equal to k plus 1 squared. 2k squared is greater than or equal to k squared plus 2k plus 1. Taking everything to the left, 2k squared minus k squared minus 2k minus 1 is greater than or equal to 0. K squared minus 2k minus 1 greater than or equal to 0. I'll complete the squares on the left, so that would be k minus 1 squared minus 2. We want to show that this is bigger than or equal to 0. So that means we want to show that k minus 1 squared is bigger than or equal to 2. We'll take positive roots here. We want to show that k minus 1 is bigger than or equal to square root of 2. Since k is positive, the minus root is not interesting here, because of course a positive number will be bigger than a negative number. We want to show that's true for the positive case. So we need to show that k is bigger than 1 plus root 2, which is about saying k is bigger than about 2.41. Now we know that that's true because the first case is 4. We have to start at least 4. So yes, k is going to be bigger than 2.41 because it's starting at 4, which means this claim is true. So our 2k squared is bigger than k plus 1 squared. So if I put these two results together now, 2k plus 1 is bigger than 2k squared, but 2k squared is bigger than k plus 1 squared. So that means we have 2k plus 1, that's bigger than or equal to k plus 1 squared. So that's really the end of the proof now, because we have shown that if you assume it's true for case k, it follows that it's true for case k plus 1. It is true for case 4, the first case, so it follows that it's true for case 4 plus 1, true for case 5, and so on and so on.